So we are going to do a problem. The problem is the decomposition of N2O5 has been studied in the gas phase according to the reaction shown below. These experiments showed the reaction proceeds by first order kinetics. So the reaction is 2N2O5, which the product and the reactants are 4NO2 and plus O2.
Just talk on Friday.
Okay, so part A, there's two parts, part A and part B. Part A says, calculate N2O5 at 150 seconds for a reaction carried out at a temperature where K equals 6.93 times 10 to the negative third seconds inverse. And the initial value of N2O5 is 0.100 molarity.
150 seconds out.
So, in order to do this, we first
Keep going.
need the equation. So we need to figure out first, actually, before we do that, if it's a first order or second order kinetics problem. The problem luckily gives us that as a first order kinetics problem, so we don't need to do any. It's less work, a little bit easier. Okay. So the equation that we're going to be using for part A is ln AT over A sub 0, the initial, equals negative KT. So what we're trying to find in part A is AT. We are given A sub 0, which is N2O5, so that's 0.100, and we are given K, which is 6.93 times 10 to the negative third, which is going to be a negative since the equation says negative K. We're also given T, which is 150 seconds, is what we're trying to find. So, in order to find this, first, plug everything in and see if there's plug everything into the equation. Next, you're going to multiply negative 6.93 times 10 to the negative third times 150, so K times T, and you will get the answer of about 1.03. So next, what you want to do is, since you can't take a ln of something, so you have to cancel that with e. So you're going to raise each side to the e power. So that will be e. So e and ln on ln n2o5t over 0.1 equals e to the negative negative 1.03. So once you do that, you're going to solve for e to the negative 1.03. And then you're going to multiply that by 0.1, which should give you the answer of 0.035 molar.
And then what's the
That's by 0.1.
Okay, cool.
So the final answer is 0.035.
Okay, sounds awesome. So what should we name this?
You can leave it as that, or you can say purple group, or whatever.
Okay.
And 0.035 molar per second is the final answer. All right, now we are going to be solving for part B. Part B states, how long will it take until N2O5 equals 0.0200 molar? So in this problem, you're going to be using some information from part A and some new information as given here. First, you're going to be using the same equation from part A, which is ln at over ln a sub 0 equals negative kt. You are given at in this problem, which is 0.02, and you are given k and a sub 0 from part A, which is 0.1, which is a sub 0, and k is 6.93 times 10 to the negative third. So once you plug into that to the equation, you are solving for t. How to do this is you're going to first divide 0.02 divided by 0.1, which equals ln 0.2. Next, what you're going to do, so then that should leave you with ln 0.2 equals negative kt. So then you're going to divide each side by k. So divide each side by negative 6.93 times 10 to the negative third. So then you should have t equals ln 0.2 divided by negative 6.93 times 10 to the negative third. So once you do that, that's how you solve for t. So your final answer should be t equals 233 seconds. And that's how you solve this problem. Thank you for listening.